So some days prior, I went on to search for ideas to make a video on. And as you guys are smart enough to be able to do easier things by yourself, so today we'll be discussing about some hard things in Python. I searched on Google that what are the hard things in Python, and it told me these are the four things. And the four things are decorators, closures and scopes, generators, and lastly, object oriented programming. See, object oriented programming is a big topic in itself. Today we'll be discussing about the above three, which are decorators, closures and scopes, and generators. So let's start. Now we'll be creating a file named as main.js. Sorry, py. Main.py, right? We'll be talking about decorators first. Decorators, okay? This is gonna be decorators. See, what are decorators first of all? Decorators, they are just here to decorate your function, okay? Whatever function you have created, they're gonna decorate it. So decorators are nothing but they are also functions which contain your function and return a decorated function. You don't get me? Let me show you, okay? See, let me create the main decorator. It's like function name main decorator. Okay. Sorry. Yeah. And it will be taking your function. Okay. The function, the function you have to run this decorator on. Okay. It will be taking that function. And now, yeah, the function. Okay, now we will first see decorator. You have to decorate something. Decoration means you have to do something before or after that function that you are applying that decorator on. So let's say I want to greet the user, so I'll be printing hello, and then at last I'll be printing bye. And this sir, okay, bye sir, and here hello sir, okay, in a respectful way, okay. Now func and this, sorry, func func and this, okay. But wait, and we have to wrap this up in a function, most probably. Let's see, yes, and we'll be returning this function, this main function, okay. Nice. Now it's awesome, okay. So if you have basic knowledge of Python, how this should work. First we'll create a function, that main function, okay, main main func, sorry, not dunk, sorry, main func def main func is this, and yeah, this is gonna be our main function, and it's gonna print I'm a function, great, and with an exclamation mark. Nice. Now we have to apply that decorator on this, so we'll be decorated func is gonna be main decorator, and we'll pass main function to main decorator. Great. Now decorated function, we'll run this, okay. Now let's see what will happen. Awesome. This is what we wanted. This is a decorator. But sometimes, but no, not sometimes, like there's a functionality in Python, you call it, that if you want to do so, we'll be adding this decorator. We can add this decorator to the function directly by using this @main decorator. And now if I'll be running this function, wait, I have to run this function, main function, and let's see if it works or not. These are decorators in Python. If you didn't get it, you can just watch it again. What we have let's wrap this up. What we have done is, there is a decorator, okay? You can name it in any way, you can give it any name, okay? Now there's a function, there's one more function, and we are making this function just to return this, okay? We have to return something, right? That's why we are making this function. And then we are doing the decorations, okay? Hello sir, bye sir. And the function we are getting will be just executing that function here. Now there are two ways of using this decorator, either by this normal method. This is most of you can get this, okay? It's easy, it's the basic one. Decorated function is equals to main decorator, it returned this main, okay? And now decorated function, we ran it and we got this. But to make things easier, we used main decorator directly in this function. We said that we told Python that we want to use main decorator on this particular function. Thus we wrote something like this, @main decorator, or name of any decorator, okay? And then when you ran this function, it worked, right? So these are decorators. Let's move on to closures. So now we will be talking about closures and scopes. Closures and scopes. Spelling okay. Now first of all, what are scopes? Scopes are like x equals to 10. If x equals to 10, then def my new function, and here x equals to 25, and if I print x, I will get something. And what will I get? Let me see x again. Let me just comment this one out. And now if I'll print this, I'll get nothing because I didn't run this function, of course. My new function, and I'm running this. I got 25, okay? X had the value of 10. Now I altered the value. I didn't. Actually, I created a new x and I gave it the value of 25. I printed it, and now it came out of this, okay? Now I'm out of the function, right? And when I'm out of the function, let me print x again, okay? And what will I get now? Let's see. I got 10. Reason being, because here when I just assigned x a value of 25, both of these x are not same, okay? They are not same. Fine, it's a new x. But if I want, okay, these are scopes actually. These indentations, if you have worked on any other language, in any other language like JavaScript or something, functions are open and closed with these, okay? So these are scopes. In Python, indentations are scope. Anything declared here, assigned here, okay, can be used here if I don't create a new instance of that variable. 10. Now x has the value of 10. Let me tell you what actually happens. I wrote print x. It will find in its own scope. If it has x, it will print that x, and if it doesn't have that x, it will go out of that scope into the next scope. See, okay. And as we have seen, 1010, when it didn't find x here, it went on to the higher level of scope. And if now I create one more function in this function, another new function, this func is okay. Now I'll print x, but wait, I'll assign it another value. I'll assign it 24 and here 25, right? It's the code is right, and I didn't have to say it. Oh, sorry, I didn't run this function. Another new function, and with these parentheses, I got 24. What's happening? X went on to find this print went on to find x's value, and it found one. Let me comment this out. It won't find. Then it will go to 25, and then it will use that that value of x, 25. See, it used it. This one is the third function, if you don't know. And to be clear, let me show one more thing. My another new function. This is by my another new function. Okay, and here this will be by my new function. Okay, and this will be global, global. Now see, my another new function, they have same value. Why? Because my another new function doesn't have its own x, so it went on to higher scope and it found x there. But what if it wouldn't have found x here also? It would go to higher scope and it would print 10. Let's see. Yeah, it did print 10. So these are scopes. Okay, and if I comment this out, what will happen? See, error. It's an error. Okay, so yeah, you have to define it. One more thing. What if I want to alter the global x? I am making some function and I have to alter the global x. Okay, it's not a good practice to alter the global variable because that's not a good practice. For example, if you're working in a big team and anyone will be altering the global variable, so it's not efficient, it's not a good practice. But just imagine you have to alter the global variable. There's just something is going on in your mind and you want to alter this. You will write a global keyword here and now x. Now what will be happening here is this function will be using global x, which means x equals to 25 will change the value of this global x. So now if we print this, we'll get 25. See, we got 25 here in the my new function. It's okay. We got 25 in my another new function. It's also okay. But I got my 25 in global. See, I got 25 in global. That's what I'm telling you. I altered this global variable. Okay, gotcha. This was scope. Okay, now what are closures? Nothing much. It's just see, I gave it something. Let's say I gave it x. Now I gave it n. Sorry, no, I can't give it x. I can give it y. I can give it z. I'll do this. Okay, I give it z. Gotcha. I couldn't give it x because x is being used here. And it's global, so I can't give it. Now, see, my new function, it's printing something. Let me print y. Okay, let me print y here, and now let me print what? I'll print Z here. I can definitely do so. Wait. Yeah, I can definitely do so. I have to do my new function. I have to give it some value. Okay. Sorry, why? I'm sorry, why? And here's Z. Okay. Here I have to give some value to Z. So I have to return this function, I won't call it, I will return it. That's it. I won't call it, I will return it. Return my another function, my another new function, I'm sorry. And I will this my new function. I'll give 10 to y, and now I'll be getting another new function equals to this. Now I can run another new function and I can give it a value of 11. So I'll be getting 10, 11. It's easy, okay? A new function 10, my another new function 11. What are closures? Closures, see, if I want it is returning my another new function. And what's in there in this my another new function? There is print Z and my another new function. It'll this what's happening in here. And when I returned it, if you by chance think that my another new function, when we are returning this, we are only returning this small part, the selected part. No, we are not returning only this part. We are also returning some values from this function that are being used in this function, but at this point nothing is being used in this function. So we'll do one more thing. This is Z, we'll print Y. Okay, we'll print Y here. And now just imagine if you think that only this part is being returned here and A and F only have this value Z, you're wrong, because we can also access Y. Let me show you. Y, we got 10. This states that whatever is being used in this function, and that has to come from above functions, it will come, and this property is known as closures. Okay, if you didn't understand it, slow down the video, I will look at it again and let me tell you again. Okay, see, I'll remove this, some spacing, it will give you a better look at it. Yes, my another new function. Now my new function, there's a function, it returns my another new function. Okay, this is my another new function. Now I got this my another new function here, and if you think that it returned only this small part and only this Z variable, of course not, it didn't. Why? Because you are using Y here, so it had to return this Y's value. Okay, so the Y, we are getting this Y in here. Okay, so it's like it is also known as back theory, I think. So it also returned all those variables, all those things that are necessary for the returned function to run. So my new function returned everything that is important to run my another new function. Okay, these are closures. That's it. Okay, so now let's talk about generators. Okay, generators. Right? Sorry. Yeah. Generators. What are generators? Let me tell you. First, it's also function. Okay. First, let us create my generator. Okay. Now, let's just imagine that you okay. You have you are running a very big organization and you want a function to give you, let's say, you have a lot of values, you have a lot of files, and a function gives you the content of those files. And just imagine you have, let's say, lakhs of files. Okay, you don't want that function to give all those files to you at once. You want that function to give you one file at a time, one file at a time. So let's say, and for that, see, to return everything, we use return. Most of the time we use return in functions to return, as we have used here. Let's comment this out, as we have used here. But for generator, if you want a function to be a generator, you just have to yield, write this yield 1. And as return can only be used one, yield can be used as many times as you want. Okay, 1 2 3. And now when I'll get a value, let's say my gen value equals to my generator, of course, my generator. Here you will get values, but to just see those values you have to use one thing, that is a next function. And now when you will write my gen value in there, what you will get? You'll get 1. Okay, you will get 1. When you will run this again, what you'll get? First you'll get 1 and then you'll get 2. And if you run it again, first you'll get 1, then you'll get 2, then you'll get 3. And let's run this one more time and it will give us an error. Okay, it ran for 3 times, but now at the 4th time it gave us error, right? Yeah, it gave us error, right? So these are generators. Now what are the use cases? Let's see. See, we can't write yield for, let's say, lakhs of times, so let us write for I in range 1 to 100. Let's say for now 100, 1 to 100, 1 to 101, 101. It will give us value till 100. 101 will give us value till 100. Okay, yield I. So now it will yield values 1 2 3 to 100 till 100. Okay, and we can use those values. But the problem is, if we won't use this yield, we would have returned all these 100 values. Okay, and returning 100 values are still small, but what if there would be crores of values? That's a huge number of values, and we don't want a function to return that much of value, because it will, of course, it will use resources and time. So we don't want that until we need it. Okay, we don't need it, so why would we do that? That's why we use generators. Now I will get one value at a time. Let's say I just want 20 values. So what I will do is I'll run a for loop again for I in my generator. You can do this directly, I think. Let us try. Okay, and I'll print I. Okay, my generator. It will give us all the values. Okay, it's till 100. But what if we just want, I said we want the values till 20 only. So I'll give it a range 1 to 21. Okay, now I will give it next and my gen value. So now we'll get values from 1 to 20. See, we got values from 1 to 20, and here we got values from 1 to 100. Okay, these are generators. We can get value from 1 to 100, but we don't need them. And when we don't need them, why would we want them, right? It's just a waste of time. Let's say there would be values 1 2 3 4 5 6. It is 1 crore. But I just want values from 1 to 20. I got 1 to 20. Else I would have used what? Let's duplicate this, comment this out. Wait. Else I would have done something like this. Let's comment this out, and now let me use it again. I would have taken a array, let's say list equals to an empty array. Now here I would have done list dot append I, and at the end I would have returned it. Return list. Okay, this is what I would have done. And now if we run this, what will happen? Actually it will take time, nothing will happen because we are not printing, but still it will take time. See, it is taking time, but it took not that much of time, but now it will take time, of course. See, it is taking time, and we don't want that. Getting me? That's why we use generators. You can use generators. How can you use generators? Let me comment this out. This is that important part. This is the real thing. My generator. Okay, your my generator, we don't want to run that. Yes. Okay, this. Okay, I'm sorry. Okay, let me tell you again what is happening. We've created a generator that's yielding values till 1 crore. Okay, but we only want values till 20. That's why we are accessing values only till 20. And how to access values of generator? First we'll get those get that value, whatever it is yielding. So my gen value, we'll get that value, and we'll use next my gen value. Okay, next we have to use this thing. Okay, this was all for this video, so I'll see you next time.